Hello and welcome to another video in which we'll be practicing integrals by substitution with more exercise. So for our first exercise, we have the integral of x cubed times 2 minus 2x to the power 4, all of this to the power 5 dx. So how do we approach solving this? Where we look for our patterns again. And we find this, if you want to pause the video before I tell you, we find that we have here x4 and x3. So if we derive this, we can cancel out this x to the power 3 over here. So let's say there our h is equal to 2 minus 2x to the power 4, and therefore our dh is equal to 2 cancels out, minus 8x to the power of 3. Now, this is dx, of course, so we have to say that dx is equal to dh divided by this, minus 8x to the power 3. And now we substitute this back into our integral, x to the power 3 times h to the power 5 times dh over minus 8x over 3. We cancel this out with this, and we are left with minus 1/8 times the integral of x to the power of 5 dh. And this is like what we have with x to the power of n, so we just solve this by minus 1/8 times h to the power of 5 plus 1 divided by 5 plus 1. This is minus 1/8 times h to the power of 6 over 6. And this is equal to minus h to the power of 6 divided by 48, which is h to the power of 6, 2 minus 2x to the power of 4, all this to the power of 6, and divided by 48, plus c, of course. And that is our integral, the solution for this integral. Let's practice with a final example. 2 e to the power of x minus 1 plus sine of 3x minus 1 dx. So here we have an integral that is quite complex. It is quite long, and we want to solve it using by substitution. Well, what we have to solve is either one of these two, so let's just go for x minus 1, substituting that. Let's say h is equal to x minus 1, dh is equal to 1, of course, dx, so basically dx is equal to dh. And therefore, 2 to the power of 2 times e to the power of h plus sine 3x minus 1 dh. But here we encounter ourselves with a problem, and that is that we have both h and x in our integral. This cannot be. We have to have only one of the two variables. And the way to solve this is basically, since we have here an x and here an x, we can isolate this x in terms of h and then substitute it back here. So we can say that this is h is equal to x minus 1, but it is also x is equal to, this minus 1 goes to the other side, h plus 1. So what we do here is 2 times e to the power of h plus sine of 3 times x, h plus 1 minus 1 dh. And we obtain that 2 times e to the power of h plus sine of 3h plus 3 minus 1, so plus 2 dh. And this is our integral with only one variable. Here we can break down into two integrals, and we can also take out this constant if we break this down. So we can say that 2 times e to the power of h dh plus integral of sine 3h plus 2 dh. We can solve this one already. 2 times e to the power of x, which is e to the power of h, pretty much e to the power of h, plus integral of sine 3h plus 2. Now, this right here is a function, so that's why we cannot integrate it just like that. We have to substitute this again by something else. So let's substitute it by u, for example. Let's substitute all of this by u, say that u is equal to 3h plus 2, and therefore du is equal to, well, we cancel basically everything, so we're left with 3h plus 2. We're left with 3 dx, so dx is equal to du divided by 3. That is what we're left with. So if we substitute this back here, we have that 2 times e to the power of h plus square root of sine to the power, sine of u du. And now we can solve this. This is going to be 2 times e to the power of h minus, remember that if we have a sine, it is equal to minus cosine of u. And now what we do is we undo our change of variable. Here we undo h by x minus 1, and here we undo u to h, our 3h plus 2, and then this we undo it back to our x's. So we're left with this, 2 times e to the power of h minus 1/3 times cosine of u. Now let's substitute everything back. 2 times e to the power of x minus 1 minus 1/3 times cosine of u, which is 3h plus 2. We substitute this back, our h here, 2 to the power of times e to the power of x minus 1 minus 1/3 times cosine of 3 times h, which is 3x minus 1 plus 2. And this is 2e to the power of x minus 1 minus, let's just write it like so, cosine of 3x minus 3 plus 1 minus 1 over 3. Obviously, plus c, never forget adding your c. And therefore, this is our result for this integral. Thank you for watching. I hope you have understood the by substitution method. And in our next video, we're going to be looking at another method called the by parts method.